and nice to see you all back in PoorConsult's YouTube channel. And in this video, we are finally starting our long journey in Solidity and Ethereum programming. So before this video, we talked a lot about Ethereum, about the entire concept, about different types of accounts that might be in Ethereum and stuff like that. But now this is the first video of the practical part, because after all, the programming, especially when we are talking about blockchain programming, is all about creating decentralized applications. Yeah, so whatever reason that might have brought you here, because probably maybe you want to become a freelancer to create to receive orders and create your own to create applications for them, or probably you have some business ideas, or you think you might have some ideas in the future and need to know how to create those, how to make those ideas come true. So you might need to create a decentralized application. All right, and in order to do that, you need three things. You need to know, first of all, Solidity, if your dApp is going to be on Ethereum. Yes, so you need Ethereum's programming language. You need to know a little bit of JavaScript, and believe me, it's not a lot. You don't need to be mastering JavaScript, stuff like that. You need to know some basic JavaScript, which we'll cover in our tutorials as well. And finally, and then you need to know some front-end programming as well, such as HTML, CSS, but just the very basics. All right, believe me, that's enough to create some simple applications. And why not, later on, once you get familiar with it, you can deepen your knowledge and create some really good stuff as well. So if we go to dapradar.com, I'll leave a link down below. You will see there are like so many applications nowadays already built on different chains. For example, if we are here and then we choose Ethereum, then we'll see here it comes. We even have categories like games, DeFi, gambling, exchanges, collectibles, high risk. These are mainly those return on investment applications. So everything in here, we see all this stuff. And after all, now we have a question. So how are these dApps built, right? So not all of them uses Solidity, but most of them, believe me, do. So even if we change, you might think only Ethereum, but no, all these like BNB, Polygon, so most of the NFTs, DeFi, it's all built on Ethereum, meaning that it all uses Solidity. So even if you are building your dApp on Smart Chain or on Polygon or on Avalanche, it still operates on Ethereum virtual machine, meaning that you are writing down the same code and then you are just applying it, you are deploying the contract on the other like Smart Chain network or Polygon network, but the code is still the same as if you have deployed it on Ethereum. So what I'm saying is that this Solidity is actually probably, I would say, like a 40% of the job. Another probably 20% is the front-end coding to make it your application look nice and stuff like that. And then another 40%, which is very important, is to kind of connect your backend code, the Solidity's code, which is responsible for the brains, the operation of your application. And then you need to connect it to the front end, for which we're gonna use React so React and JavaScript. But for now, we just forget about it. It has yet to come. First of all, we need to learn some basic Solidity. Okay, so after completing this course, which consists of several videos, not only one, you will know the basic Solidity and will be ready to use this knowledge in order to create decentralized applications. And we'll have several applications, so at the end you will know not only this backend language, but also the front end, the ability to connect it together and then have the entire program up and running, the application, be it a decentralized exchange, be it whatever it is, whatever idea you have. It can be some liquidity pool, some business ideas you have. We'll have some examples of real live applications deployed on the blockchain, so you can copy them, you can use the same, or actually you will have the ability to do it by yourself. All right, so without further ado, let's start our journey. And first of all, I will link down below again. This we go to remix.ethereum.org. This is an IDE to write your Solidity contracts, and then the machine will compile the contract into, will compile it and make the code understandable for the machines. So we just, it will turn it into the bytecode for the machines, but we don't now go into that. You don't want to deepen now into the theoretical part. Let's get to practical stuff. So once you come here, first of all, let me get you introduced to this to the interface of the website. So on the left, what you need to pay attention to is just once you come here, you see here the contracts, right? And then you are given the 3 contracts as an example. All right, so this is just example. We don't need to use them. What we do need is this first line of code, which identifies the license, and not go into the details what license is, how to use it. Just know it's a public license, you all can use it. So we'll just copy this first line and that's it. And we have the owner, storage, we don't need, so we just click on, let's click on new contract. So all the Solidity contracts are ending at .sol. All right, .sol means that this is written in Solidity, the code. So let us call our first contract our contract. Yeah, let's call it our contract. All right, press enter. So that's it. So right in here on the right side, we're gonna write our contract, and then after we do it, we come on here on the left side, you see this icon, yeah, the second icon. So what is it? Okay, but let's go step by step first. You'll get confused. So first of all, in here, as we said, we just copy this identifier, the license identifier, copy it and then paste it in there. All right, so this is our identifier we have, and then we start writing our code by saying that this is a smart contract. Yeah, yes, it should be a smart contract. So the first word is contract. All right. Oh no, actually before doing that I forgot. We need to specify that this is a Solidity. We are writing a Solidity code, and we need to mention the version of Solidity. Okay, so first of all we go with pragma, and then we call it Solidity, and then the version. And for the version, okay, so that's why we needed this tab that I just told a second ago. So this is a compiler. All right, so the version of Solidity that we're gonna mention in here, let's say we mention 0.8.0. okay, this version of Solidity, and each line in Solidity should end with a semicolon. All right, if so, don't forget. If you forget this semicolon, it will show a mistake. All right, it will show a mistake. If we save it, we'll see that there's a mistake, and then it says it expected the semicolon but didn't get it. So it tells the machine that the logic ends in there. All right, so without the semicolon, it just continues and it doesn't find the end. So we need to put it there. All right, then when we save it, we see. Well, we need. I'll tell you why is this mistake in a second. So first of all, we need to specify the version of Solidity, and in here, if we come to here, this compile button, we'll see that we need to choose the compiler. So this program, it will compile the language into the bytecode, so as the machines understand it. All right, this is a process that automatically is being done, but we need to make sure that the version of Solidity we've written here matches with the compiler version. Okay. So I will probably later on I will show you the Ethereum documentation, and this Solidity is being changed quite often. All right, very often, and the thing is that with each version, now you see we compiled, I just clicked auto saved, and then it has this green check mark saying that our code now is compiled, even though there is no code, but the version of Solidity is the same, so we are good with it. So these Solidity versions are being updated quite often. All right, so you need to better check the documentations, because once the version changes, there are sometimes mild changes, sometimes some serious changes made in Solidity, so you better be aware of it. All right, so I will post the link, and I will even show you the documentation page later on, so as you know what each version tells with it. Okay, but for now we just waste time on it, so we continue. And what we do is, so once the version of Solidity is done, we go on. Another thing I want to show you here, okay, let's not forget, you can add on here this caret button. All right, the caret sign, which means that any compiler version 8 and up, okay, and higher than 8 is good. So even if we here choose 8.2, we still are good. If we click on save button, you see that the code is still getting compiled successfully. You see the green check mark. So but for our case, I just want to be like 0.8, all right, the 8 version of Solidity. So we choose back version 8, and now we're good. Okay, so after identifying this, we need to keep on writing, and then we just type the word contract, yeah, our contract. And how did we call the contract? It was our contract, right? So it's just a good practice to call here the same as you have called the file with, okay, this file in here, our contract. But you can change it, it doesn't matter, but just like keep on the good practice. So just write our contract, and then we open up these curly braces. Okay, so our entire code is gonna be written in these curly braces. Okay, so this is the place, this is the container, the box, you can think of it, where the entire code will be written in. All right, so that's it. And then we need, so our contract, we need to specify the variable, which call it a name. Okay, let's say name, and then we say that the name is, let's say, PoorConsult. Okay, let's say PoorConsult. Okay, so that's the name. That's the name of the variable. We call it PoorConsult. All right, and then you need to specify, so this is called a state variable. All right, this is a state variable, but we need to say the state variable, we just give it the name public, I mean the type public, meaning that anyone after the smart contract is deployed, and later on after our application is ready, even without application, I mean we have our smart contract deployed on the blockchain. Once we do it, if it is public, it means that anyone can access this variable, okay, can read it, can read the value of this name variable, which in our case is PoorConsult. And then if we add some functions later on, they will be able to alter this value, to modify it as well. So we'll go on the theoretical part, and I will tell you exactly which type of which types of these variables can be, like external, private, public, okay. But for now, I just don't want to push lots of theory on it, so let's keep it simple and practical, okay? And then we just specify string, okay, because it's a string, right? The type of this variable is a string. It could have been integer, unsigned integer, okay, but now it's string. It's not a number. That's what I'm saying. It's a string. So string. Oh, you see, I forgot. What did I forget in here? I forgot semicolons. Okay, so string public, meaning everyone can access it, name PoorConsult. All right, so this is our smart contract, guys. It's ready. Yeah, it seems funny, it seems too simple, but this is ready. If we just click on save button, we see that it's compiled. And then what we do after it's compiled, of course, you can have this check mark on here with auto compile. I just like to do it manually, but if you click on here a check mark, then once you type the code, it will get compiled by itself. Yes, and so that's it. And then we come on here on the left, this bar, you see the last button here, which is deploy and run transactions. All right, so here you just pay attention, we need to understand what it is. So after we have our contract written and it's ready to be deployed, yeah, which means to be on the blockchain, this is where we're running it on here in our local IDE. Now if we want to deploy it on the blockchain and make it accessible to everyone, okay, so we need first of all to choose the environment. So the environment can be, you see the first two with no difference, like JavaScript, virtual machine, and then we have injected Web3. So if we click on, if we first of all, now we are just trying, yeah, we are not deploying it on the actual blockchain. So this, we have the JavaScript virtual machine, which is a virtual environment. Call it a virtual blockchain on our machine, so that we can deploy this contract and then test it, see how it works, see the different functions of the smart contract before actually deploying it on the blockchain. Because once we do it on the blockchain, then we need to spend gas, we need to spend money to do so. So we don't want to do that, and it's not ready yet. We are just trying it out, so we need to have it on our local machine, the virtual environment. So click on London or Berlin, it doesn't matter. And then And then you see this remix has created several wallets for us. Of course, this 100 Ethereum is fake. It's test ETH, right? Don't get too excited. You can't spend it yet. And never, I say, I mean, from this wallet, because it's fake. Yeah, it's just for test purposes. So click on whatever you want. This is the first one. And then here, again, let's not pay too much attention on what is gas, the value. We just don't need it. We just click on here, the contract. Make sure this is our contract is chosen. And that's it. And then we click on this deploy button. All right, so we see right here on this on the below this window, we see that our contract, something has happened here, and then our contract, we see this green check mark, and the contract has been deployed in our virtual. It took a second, not even a second, because it's in a fake environment, but still it's deployed. If we come in here, we see that deployed contracts, click on our contract, and then see a button here called name. If we click on it, we see our name, so a type of string, PoorConsult. You see, so how did it happen? Is because in Solidity, you need to know that in Solidity, every time you declare a variable, like here, the name variable, you declare it public. Once you declare it public, so under the hood, it automatically creates a getter function for it. All right, so which allows Solidity to return the actual value of the variable. All right, so the getter function, because this variable is called a state variable, and for state variables, once we give it the public attribute, all right, the Solidity generates for us the getter function, and the getter functions are those functions that read the information from the blockchain, from our smart contract. They never change it. All right, that's why even if the contract was deployed on the blockchain, then when you call this getter function, it just reads the variable information. All right, it passes the information from the blockchain to you. It doesn't cost gas, or probably, I mean, it actually does cost a little bit, but you don't pay for it. All right, so it's free. For other type of functions are not getter, are setter functions, and for setter functions you alter the state of the blockchain. All right, you change the state of the blockchain, so you must pay gas to do so. Every time a state of the blockchain changes, then you have to pay gas for it. All right, that's because the miner should confirm the transactions and stuff like that. But for now, this is a getter function. It only reads data from the blockchain, even from our virtual blockchain, so we just don't need to pay gas for it. Okay, so this getter function was generated automatically, and by clicking on it, we can read our data. All right, so simple as that. If we wanted to deploy this contract on the actual blockchain, we could have chosen this injected Web3, and when we do so, the MetaMask window will pop up, and depending on whatever chain we are on, Ethereum mainnet, Smart Chain, Polygon, and different EVM compatible chains, let's say Ethereum, if we are on Ethereum blockchain, then we just confirm the transaction, and our contract could have been deployed on the mainnet or even the testnet, which obviously we're gonna do also, just for you to know how deploy the contract on the testnet or mainnet, not this JavaScript virtual environment, but not for now. Okay, not for now. All right, but we are not done yet. All right, so I just want to keep it all, I just want to finish it in here, so we are not done yet. Now we continue, and now let's have a function. Okay, let's have a setter function. All right, so this was the state variable. We had automatically generated the getter function. Now let's type in a setter function and see what we can do with it. So functions, we need to have functions to complete some actions, okay, whether read data from the blockchain or change data. Okay, so we can have even written the getter functions as well to read something. Besides the fact that it's automatically generated, we could have specified the different getter function to read something else, like to access some other data. But now we're just writing a setter function because we need to change the state of the blockchain. We're typing the name, like function. Okay, so in here we say contract, right? In here we say string. Now we got functions, and what's the name of the function? Let's say we want to update the name of the contract. Okay, so we call the function name update name. Oops, update name. update name, which is difficult for me to talk and write at the same time, sorry about that. And then brackets, okay, update name. So this is our function. And again, so we need to specify that it's a public function. All right, we want it now to be a public function, and that's it. And then curly braces, open it up. So here pay attention that once we type the name, we started with the second word. If the name consists of like two words, update name, then it's just a common practice to like a convention to write it with a capital letter in here, so as the developer or any other people looking at the code, it can be easier for them to read it. Okay, if we had the third name in here, like update name and whatever third word, then it also should have started with capital letter. Okay, just pay attention to it. So now our function is ready, and we need to type in some logic in here, what we want to do, how do we want to update our name. And what we want to do is that we want to say name equals, all right, so curly braces, and I mean curly braces, so just no curly braces in here, and here we want to type in the name it's gonna be updated with, and let's call it I don't know, something like PoorConsult 2. Okay, PoorConsult 2. We updated with PoorConsult 2, and then again semicolon to specify that the logic finishes in here. So this is our setter function. Okay, what we say is that we want to change the state of this variable to make it from PoorConsult to PoorConsult 2. Now if we save, we see that we have a problem in here. Let's see what it says. Oh, it says, first of all, why functions? It should be function, yeah? Function. So this was obvious mistake. Probably you haven't done it. Now, after we saved it, it's ready, and let's first delete this deployed smart contract. All right, another thing to you to pay attention to is once we have the smart contract, once we write it, we can have different instances of this contract. Okay, so the contract is here, is unchanged. I mean, it's here and it's fixed. We have written it, but then we can deploy it many times. All right, we can deploy the contract on different blockchains. The same contract can be deployed at the same time on different blockchains. We can deploy one, and then we can change some function, delete some function, deploy again. So all these are called instances. All right, they are instances of our contract. Okay, so once this is ready, again we're gonna deploy. And now once it's deployed, we come in here, we see that we have these two buttons in here. The blue button, or whatever color this is still this getter function. All right, if we call it, we still see that our variable, this name variable, has still the value of PoorConsult. However, now we have this new button, which is update name. Just we called it here, yes, specified. So this is a setter function. And what do you think is gonna happen once we click on it? Yeah, take your time. I mean, it's obvious, right? Once we click on it, something happens under the hood. And then if we check the value of the name again, all right, we see it PoorConsult 2. So every time we click on this, it changes the value of this name variable, of the state variable. And then once we click this name icon, once we start this getter function, yeah, we want to read the value of name variable, we have it changed to the one that we set just a second ago. Okay, so this is what this function does, and actually this is how it works. And finally, the last part, this video is getting too long, but I just really need to finish it. So let's include the idea of parameters. Okay, so what are parameters? So parameters, they can actually tell the function that we want to give you a value that you need to update the name variable with. So we want to create a function and then tell him that, hey, we are giving you a specific value that you need to update this state variable with. Okay, so I will write it down now, and you will see the difference between this function with parameters and the parameter and the function without a parameter. Like here, you see it's empty, there are no parameters in here. So let's type in function again, all the same. Again, we're calling it update name, or again update name. We're opening it up, and then So for now, let's just continue. Again, specify it's public. All right, open up the curly braces. Okay, and then now we're typing name equals. Okay, so here what's the parameter? Let's add the parameter, and the parameter for here, let's say it something like new name. All right, new name. Okay, so this new name is our parameter, and that means that this name equals new name. And for parameters, this is just again a common practice to start it with this sign, okay, in here, just to specify that this is a parameter. Okay, we need to do it. Okay, so far so good. Now we continue, and but now it's not ready yet. If we try to compile, we'll see that we have an error. And where is this error coming from? And the error is coming from that we haven't set the type of this parameter, and we should write a string. Yeah, it's a string, because we need to help Solidity. We need to tell it that the parameter in here is not gonna be a number. Okay, we're just trying to make its work job easier by specifying the type of the parameter that we are going to pass through. Okay, so it's string. But even now it's not ready, because why is that? It's because there are some types of variables in Solidity, which again we're gonna study more in details later on, that need to specify the word, they need to go with the word memory. All right, so what is a memory? First of all, what are these types? It's like strings, mappings, structs, and arrays. All right, these four types of variables in Solidity should go with the keyword of memory. And if you think of memory, it's like a RAM in your computer. So it's a temporarily memory. Okay, it's a temporary thing. For example, these state variables, those are kept in storage and they are there forever. Okay, however, here we just want to tell that we want this parameter, the value that we're gonna pass in, we want these to be kept just a second in memory, and then through our function, you see it's being transferred to our state variable, and then it alters the state of our name variable in here. So we don't want it to keep there forever. Okay, so we might change it from time to time. So this means this might go with the word memory, just like the hard drive in your computer and then the RAM that you have in your computer. Okay, all right, so and now if we click the save button, we see that we still have a mistake. Let's see what it says. Oh, we forgot the semicolon, of course. You see, I told you not to forget it, and I am forgetting it by myself every time. All right, funny, right? So it's now ready, and again, let's delete it. We can even leave 2 instances of the contract, but just to make it simple. And now if we click on deploy button again, we'll see it's deployed. We come on here. Now we see 2 setter functions. Okay, actually this one we didn't need at all, but whatever, it's done, so let it be there. Now we see that the difference, you see, actually we need it, which is just for the differences to be obvious. You see that our second function now has the field for parameters, so we can type in the parameter in here and see how it changes. So again, if we click on this getter function, we see that the name of our variable is PoorConsult. However, unlike with the first function, we can set a value for this function. Okay, the first one, it just, you see, if we click on it, what it did, it just changed it to this PoorConsult 2. But now we can change it to something called I don't know, let's say just like the word consult. Okay, consult. All right, consult, and then we click on update name. Now let's see, the moment of truth is in here. Click name, consult. You see, the name now got changed to consult. All right, and that's it. So this center function gives us a chance to change the names of our state variables anytime we wish, just by typing in like my consult, whatever values we want, clicking on update name again, and then it's my consult. All right, so guys, that's all for this video. We have our contract written, the simple, very simple contract, but it consists of two functions. All right, two setter functions. We have generated the getter function automatically, and we are actually deployed our contract, even though it's on JavaScript virtual environment, but still it is deployed, and that's it. I mean, you can play around, you can do, and in the next videos we'll continue with the logic of our smart contract and learn much more. So guys, if you like the content, if you want me to continue with this series of videos dedicated to Solidity and blockchain programming, please press the give the video the thumbs up, and get subscribed to this channel. It really helps, and and see you in the next video. Hope you like it. Goodbye.